When we investigate the nature of arguments and the difference between good arguments and bad arguments, good reasoning and bad reasoning, we can take a semantic perspective or a syntactic perspective. According to the semantic perspectives, what we are concerned with is so-called logical consequence. And this is represented in the following way. So we have here the sign that we have seen already a number of times, this sign with a vertical bar and two horizontal bar. And on the left-hand side of this sign, we see the premises. So phi 1, phi 2 up to phi k are just a series of premises that we have in our argument. Whereas what's on the right-hand side of the sign is the conclusion. And this expression means that given the premises phi 1, phi 2 up to phi k, the conclusion psi, the formula on the right-hand side of the sign with the vertical bar and the horizontal bars, the conclusion phi follows deductively from the premises. Or more precisely, that all valuations v that make true the premises phi 1, phi 2 up to phi k, these valuations also make true the conclusion psi. This is the semantic perspective to evaluate whether an argument is good or bad. So it's to look at valuation, it's to look at situation in which the premises are true and situation in which the conclusion is true. And if it is indeed the case that whenever the premises are true, the conclusion is always true, then we can say that the argument in question is a good argument, is a deductively valid argument. We can, however, take a syntactic perspective to this problem. And instead of talking about logical consequence here, logicians often talk about derivability or proof or provability. We can write this using another symbol, namely the symbol with a vertical bar and only one horizontal bar. So this is different from the symbol that has a vertical bar and two horizontal bars. And whenever we have a derivations or a proof from the premises to the conclusion, we can write that symbol. It's the symbol of derivability to signal that. So this expression here means that there is a derivation whose assumptions or whose premises are phi 1, phi 2 up to phi k, and whose conclusion is psi. So the topic of these and the following videos will be to explain how we can construct such derivations and what kind of rules we need to use to construct these derivations. Before we get into the details of what rules we need to apply and use to construct such derivations, you might want to know as a preview what these derivations look like. And here is an example of a rather complex derivations. So here you see that derivations have a tree-like structure. The conclusions comes at the bottom. So here is the conclusion right here. And these horizontal bars signal various steps in the derivation. here is another, here is another, here is another, and here is another. So these are the various steps of the derivation. Here you see refer to the various rules of the derivation that are used to go from a previous step to the next. So we will describe and explore all these rules